afternoon, everyone. How are you doing after the lunch? Good? This is my fourth time at Enlit. It's starting to feel a little bit like a family reunion, so it's happy to see some friends and friendly faces in the audience. Previously, I talked about the prospects of hydrogen in power generation, about the role of flexible power plants in modern power systems. In all honesty, I did not expect this topic to come even last year. But data center is the new kid on the block. Everybody wants to understand it. Everyone wants to have a better grip on it. So let's give it a go. Today, I would like to give you a bit of overview on the key market trends and share our views and experience in this industry. So I guess by now you already figured that our life is becoming AI enabled. Our phones, our cars, our health, our IT, even the golf clubs are designed by AI. But let's not forget that it comes at a cost. AI models are trained by billions of data points and parameters. That requires 10 to 20 times more electricity and energy than traditional general purpose data centers. And this new energy needs to find, this new capacity needs to find its place. Let's take a look into how these data centers are built. They are anchored on three pillars. We've got the IT infrastructure, the power infrastructure, and the cooling infrastructure. Normally, the CPU usage and the cooling takes up 80–90% of the energy consumed by a data center. And the energy is anchored on three pillars. We've got the primary energy infrastructure, backup power, and then battery and UPS system, all doing different jobs. It doesn't look complicated, does it? Now, the challenge is the following. Historically, data centers were used for storing energy, for enterprise software services, and some other fairly simple applications that were, to some extent, following the human behavior. In the mornings banks started to run their servers, started to run their operations. The load picked up, there was a bit of white noise, there was a gradual ramp up, ramp down, and then on the weekends, typically utilization was a little bit lower. Now contrast it with the energy use and the consumption of modern AI-based data centers. You can see a simulation or illustration made by us. The AI-enabled data centers, whenever they run a batch processing exercise or a training model, we see them operating at a sustained high near-peak utilization, but as soon as a job is finished, they suddenly drop the load. And this load can be dropped in a time frame of seconds. And whenever a new exercise starts, the load picks up again. Now, this change in the power consumption gives a lot of headache for transmission system operators. And they're already having enough struggles integrating renewable energy sources. So they are becoming extremely cautious by adding these data centers to their systems. Hence, they are requiring more studies, more permitting, more advanced protection systems, and this takes a lot of time. The International Energy Agency forecasts that in the next 5 years, 20% of the data center projects will be delayed due to the slow permitting process. To give you an example from the US, in some regions, getting a grid connection permit for a data center can take up to 5 to 7 years. So we are talking about data centers that are operating in a much more hectic and erratic fashion, and data centers that are becoming much bigger. One thing is true for data centers: they don't have 5 to 7 years to wait until they get grid connection. So in quite many instances, they decide, you know what, I'm going to set up my own operation. I'm going to run the data center in an isolated mode, and then down the line, if we get a grid connection, we'll see which one is a better option for us. One thing for sure, more data centers will require a lot more energy, but let's see how much exactly. In 2024, the global power generation capacity for data centers was around 80 gigawatts, which is 2.5 times of the installed base of Thailand. And the data centers altogether consumed 1.4% of the global electricity demand. It's equivalent of Poland's electricity consumption. Now, fast forward 10 years, the data center capacity is expected to increase 5-fold. The energy consumption will increase 4-fold. And if we combine all the data centers together, they would be the 4th largest country based on the energy demand. And the contribution of data center consumption in the total electricity mix can take up to 4.4%. In developed countries such as US, Singapore, Japan, this number will fluctuate between 8 to 10%. And if you think it's unrealistic, you need to know that in Ireland, already today, 20% of the electricity is used by data centers. And there are 6 states in the US that are consuming, where the data centers are consuming more than 10% of the electricity. Speaking about the US, as of today, the US is the biggest and the leading data center market in the world. In the next 10 years, 70% of data centers will find their home in the US, Europe, and China together. However, in 2028, Bloomberg expects a shift when the Asia-Pacific region will overtake the dominance of the US and will become the largest data center market globally. This will be led by the rapid uptake in data centers in China, which will make up for half of all the data centers installed in this region. China, quite a closed economy. I think most of the data centers will be covered by Chinese suppliers there. So let's curve it out and let's focus on the rest of Asia. In the next 5 years, Bloomberg expects 20 gigawatt additional generation requirement for data centers, primarily coming from Japan, Korea, India, and the rest of Southeast Asia. We see a lot of movement in Malaysia, in Indonesia, and in Singapore as well. As of now, most of the announced projects are grid connected. However, we see that the low-hanging fruits are being picked, and then the easy opportunities are running out. It's becoming increasingly difficult to find a suitable location for new data center projects. With my colleagues, we participated a few weeks ago an energy exemplar, energy modeler user group meeting, and half of the discussions there were about optimizing the energy use and location of data centers, which is a clear signal that this shift is happening in this region as well. More data centers, more power consumption. The power has to come from somewhere. There will be clear winners and losers of this game. In the next 5 years, Bloomberg expects that coal and natural gas will benefit the most of this surge in power demand from data centers. Due to the data centers, the world will accommodate 100 gigawatts more gas-powered generation capacity. 2/3 of that will be addition of new plants, and 1/3 will come from delayed retirements. It will be also positive for coal plants. However, we expect that most of the coal additions will not be actual additions, but more delayed retirements. All in all, due to the higher demands, globally, gas power plants will operate 1.7% more average per year, while in the US, this number can increase up to 4.4%. Now, I know we have a nuclear energy consultant here in the room, I got the question, why don't we see the nuclear on this chart? Because a lot of the US projects are based on nuclear supply. Well, Bloomberg is very cautious and very careful by making any projections nuclear. So they added in their report with a disclaimer that that's probably the biggest wild card in their predictions. Now, this is a utility conference. So what do utilities and IPPs want? They want low cost, high reliability, and sustainability. When we talk to data center developers, we realize that they have another priority, and that's speed of delivery. Especially co-location data center developers are extremely keen to get high reliability and fast delivery. A data center project is typically executed in 18 to 24 months. That's why the 5 to 7 year wait time is just simply not possible for them. And that's why many of these co-location data center developers are scaling a little bit down their sustainability ambitions in order to meet the commissioning deadlines. Going back to the reliability, the industry benchmark is the 5 times 9% reliability. On that note, I can say that with Wärtsilä, we can guarantee you 99.9% availability, and the remaining 2 nines will be taken care of by the UPS and battery systems. How do we do this? This is an example I brought from the US, where we give a quotation to a data center developer that is requesting over 200 megawatt committed generation capacity. In this configuration, we provided a proposal based on 25 engines, each with a size of 11 megawatts. And with an N+4 configuration, this power plant will be able to provide a 99% availability for data centers. The average engine loading will be 91%, and the engines will register 7,300 running hours a year. A bit of an illustration on how it's done. This orange part shows you the available generation. The gray area shows the spinning reserve, while the orange line shows you the actual available capacity by the engines. But you can see that even when the engines are on planned maintenance, and if there is an unplanned outage, they will be able to meet the contracted requirement of the data center. I brought you 3 references from Wärtsilä. We have a partnership in Ireland with a developer called AVK, where we are, one of our projects is a 110 megawatt power supply project for a captive data center that will have 2 engine halls that are providing the primary power. The data center will be still backed up by high-speed engines. It will also accommodate an uninterrupted power supply system and a set of batteries, and will have a grid as a backup. In this configuration, the data center is meeting the Tier 4 reliability requirements and is expected to be commissioned next year. Another example, also from Ireland, is a 90 megawatt project where we are building 3 power plant blocks. 2 of them have been already signed. Last one is under discussion. We expect to bring that one online in 2026, 2027. And then to finish with a big bang, this summer we signed our first and biggest data center deal in the US, 282 megawatts based on our 15 of our largest engines as of today, that will provide a primary source of power for a data center in Ohio. The project will be executed by 2027, and with this one, our footprint exceeds 6 gigawatts in the US, which, by the way, is still a lot less than what we have in the Middle East and Asia. Walking around the exhibition floor in the past couple of days, one thing I learned is that the IT guys need to talk to the energy guys to further work on data center projects and to remove the obstacles and to bring the viewpoints closer together. So I would be happy to learn from you, learn from the IT experts, learn from the other energy experts, and see how we can further together move this industry further ahead. Thank you very much.